Okay, so today let me cover another topic called delegates. Okay. Delegates are one of the, in my opinion, the neatest things in C#. Okay. If you, as you guys have taken a look at C#, most of it is similar to, let's say, Java or C++. Okay, there are a few things in C# that are different from other languages, and one of them is delegates. So, in my opinion, this is the part that makes this language probably better than Java or better than C++, right? So, why are delegates so neat? As I will demonstrate to you, delegates lead to what are called anonymous methods. Okay, anonymous methods lead to a concept called lambda expressions. Okay. Delegates also lead to a very neat event handling. So for example, if we click on a button or we select a menu, how do we know what should be triggered? As you will see, all event handling is done through the delegate mechanisms under C#. So anyway, lambda expressions further give us a very powerful concept called task parallel library. So it basically simplifies multi-threading. So we can write very efficient programs that take advantage of the multiple cores in our system. Okay. So anyway, let's take a look at what is the concept of delegates and what are anonymous methods, lambda expressions, and so on. Okay. So what exactly is a delegate? Delegate is simply an object-oriented form of a pointer to a function. Okay, so the job of a delegate is simply to point to a function, right? Once we are pointing to a function, we can make a call later on. So to give you a simple example, suppose you created a class called XYZ, and suppose you put something public double, let's say compute int A, int B, okay, and you did some computation, you returned some result. Okay, so once you've written a class, if we wanted to point to this function, right, this is where the delegate comes into play. So first of all, delegate is a type, just like class is a type, right? So remember we had discussed some time ago the concepts of types in the .NET system, and we had talked about we have what are called value types, we have what are called reference types, right? Okay, what are value types? For example, standard data types, right? So for example, standard data types, int, double, byte, and so on, right? Value types, as you already know, are created on the stack, correct? Okay, what are reference types? Reference types are created on the heap. right? And what are the examples of reference types? For example, class objects. Whenever we allocate memory for an object of a class, we allocate it on the heap, right? Anybody remembers another type of reference types? Arrays. Arrays. Memory for arrays is always allocated on the heap, so arrays are reference types, right? What else? As we are discussing delegate, you will see delegate as a reference type. So that means once we create a delegate, the memory for it will be allocated on the heap, right? Okay, so now coming back to over here, just like the class is just a template, meaning nothing exists in the memory until we create an object of it, right? So for example, let's say I have some double, let's say pi equal to whatever, 3.14, right? So the memory for pi is not allocated until we create an object of the class. As soon as we say xyz, x1 equal to new xyz, right? This is where the computer will go to the stack area, okay, xyz, x1, it will create a reference called x1, right? Then new xyz, so how much memory will it allocate in the heap in this example? The only field we have is pi. So we'll allocate memory for pi. Okay, what else? Does it allocate some more memory in the heap? If you recall, it will also allocate memory for vtable pointer, which will further point to the vtable, which will further point to the type info, right? Okay, so just like we don't get any memory for the fields until we create an object of the class, very similarly with the delegate. So first we will declare a delegate, then we will allocate memory for it, right? So how do we create a delegate? The good news is because the job of a delegate is to point to a function, creating a delegate is just one line of code, okay? Or defining a delegate is one line of code. So anywhere outside of a class, we can go and say, for example, if our goal is to point to this function, right? The signature of this function is double. Let me call it cdel, short for compute delegate. Okay, then let me say int p int q. So I'm trying to match the signature to the function that we are interested in pointing to. Okay. So once the signature matches, and we can call it anything we feel like it. We don't have to call it cdel. We can call it mydel or mdel or compdel, whatever you feel like it. Anyway, then the last thing you need to do is, just before it, you have to add the keyword delegate. So this one line of declaration, as you can see, will end up creating a delegate called cdel, which is capable of pointing to a function that takes two integers and returns a double. Okay? So just like a class, it's just a declaration. Nothing exists in the memory. Okay, if we really wanted this delegate to point to this function, we have to create an object of it, right? So somewhere in our button handler or whatever, we may write this code. We may say xyz, x1 equal to new xyz. Then we will create one object of the delegate, new cdel. Okay. Now we cannot leave the constructor of a delegate blank. You have to pick a function to point to. Okay. Since we are interested in pointing to the compute function, all you have to do is x1.compute. Okay. So as soon as we execute this line of code, what will happen? B1 is now pointing to this function. Okay, if our goal was to make a call to this function, we can simply say, for example, double result equal to B1 of 5 comma 7. Okay, so now this will end up calling this function, bringing the whatever the result is, and giving it to us. Okay. So to summarize, what is a delegate? Job of a delegate is to point to a function. Very simple, right? So it's like a pointer to a function. Okay, so then you might say, well, pointers to functions exist in C, C++. So what's new about a delegate? Okay, as I will demonstrate it to you soon, it is more than a pointer to a function. Okay, it has a lot more capabilities. So that's why I mentioned it's an object-oriented form of a pointer to a function, right? Delegate is a reference type, meaning once you want to use it, you have to create it on the heap. So take a look over here. Once we declare the delegate, we use the new keyword, correct? So that we can allocate the memory for it on the heap. And constructor for delegate cannot be left blank. You have to pick a function to point to. Okay. So notice we're not calling this function. If we were calling this function, there will be a left paren, right paren after the name of the function. We are simply pointing to the function. So that's why it's just the name of the function. No left paren, right paren after the name of the function. Right? Okay. So once you learn this concept, the natural question that will come to your mind is, it seems like a useless thing, because if the goal was to call this function, right, why even create a delegate? As soon as you create this, why can't we simply say x1.compute 57? Right? It will do the same thing. Everybody agrees? Yes. Okay, so why even create a delegate? Okay, and the answer is, for these simple situations, we will not create a delegate. This is a lot easier. But as I will show you, for more involved, more advanced situations, a delegate will make our life quite a bit easier. Okay. So anyway, we'll learn those situations where delegate makes a lot of sense. Okay. So second concept, after learning how